The National Defense Education Program Pre-Engineering Program brings training to teachers and experiences to students. The Naval Surface Warfare Center, Panama City Division, in conjunction with Florida State University, Panama City, combined efforts to connect engineers, teachers, and students at the STEM Institute. STEM stands for Science, Technology, Engineering, and Mathematics, all professions needed for our nation's defense and global economic competitiveness. This 3-week event, housed at the Florida State University Hawley Academic Center, connected teachers and engineers in a full week of professional development. Teachers from 3 counties converged June 8th through the 11th to train with engineers on robotics, environmental analysis, electronics and sensors, and water rockets. Teachers worked in teams alongside engineers from the Naval Surface Warfare Center, Panama City Division, as they practiced the activities that would be used during the STEM Institute. Master teachers who had been trained by Garrett College, along with instructors and engineers from the College of William and Mary, designed the STEM activities. The training for teachers and engineers would be used with students in the following weeks. Teachers and engineers were paired as a team for the camp with the expectation that this partnership would continue into the school year. Teachers worked with engineers to solve problems and to practice with materials and equipment unfamiliar to them. The team approach to learning gave practicing STEM professionals an idea of what classroom teachers do, and it provided classroom teachers practice in hands-on learning while informing them what engineers and other STEM professionals really do.
It showed me as a teacher that I definitely need to do more hands-on activities in the classroom and to work more with the engineers that we have available for us here in town. Honestly, I didn't really understand what engineers did on a daily basis, but they just opened my eyes to the different levels of education needed to become an engineer.
These are Navy engineers that we're using, and now they're working and showing and sharing this knowledge and practical experience with the teachers. The teachers have the knowledge and ability to actually teach the young people in the classroom, and when we pair them together, we bring practical knowledge with actual classroom teaching knowledge.
For this entire week, teachers played the role of students, guided by their engineer partners. By week's end, both engineers and teachers had gained a better understanding of the skills and expertise required in each profession, and engineers had committed to joining their new teacher friends in their classrooms during the school year.
The interaction with the teachers worked pretty well. Being a scientist, I'm more comfortable with the hands-on aspect of the development of the different projects, where they're better with just management of the kids and all that. And it was pretty good to see the teachers also learn through the process and experiment with the robots and work with those and start to build some technical skills that they could bring back to their classroom.
During the robotics sessions, students put their engineering skills to the test by designing and programming a Lego Mindstorm robot to navigate 8 challenging missions. 5 distinct missions were completed individually, and the ultimate goal was to complete the entire course with 1 robot and 1 program. Additional remote explorations allowed students to discover the various uses of autonomous vehicles by designing and programming the team's robot to explore an obstacle course featuring the ocean. Teachers and engineers facilitated student learning by asking probing questions as students used their problem-solving skills to successfully complete each mission.
My group leader taught us how to do it, and then we worked together to get our robot to work. He didn't tell us, he just helped us, guided us through it, and we learned how to do it on our own.
The final activity requires students to program their robot to race each other. As teams cheered their robot on, the race ensued.
Our team worked together really well. With Zach, he was very smart. He knew how to program robots really well. And we had a lot of people that were really good at cutting and making a good model for our design problem. And the robots, we worked together really well to make them execute their missions and do exactly what they're supposed to do. I would definitely come to the STEM Institute next year. It was a lot of fun. It was a lot of hands-on projects, and it was just a fun way to spend the week.
Another group of students began their STEM experience working with equipment and learning how to conduct various analyses of water quality, turbidity, and how to test for certain contaminants in water. Students recorded their data and analyzed what that data meant, all the while working within their groups to form hypotheses. Near the end of the week, students waded into St. Andrew Bay, seining for creatures that reside in this vast estuary. Students located crabs, shrimp, small fishes, snails, and even a seahorse. From this activity, students were able to form hypotheses on the kinds of creatures who live near the shore, as well as their particular adaptations for residing in this area. Middle school students spent another portion of their day designing water rockets for testing later in the week. Once constructed, various launch conditions were tested to determine the best combination of water volume and air pressure, resulting in the highest launch. Students learned some applied physics involving Newton's third law of motion and how this basic principle applies to rocketry. The challenge was to design a rocket which would reach the highest altitude once it was launched by determining the best fuel-to-burn rate combination. Students had to plan for keeping the rocket stable and on course for its brief trip above the parking lot. Students lined up, awaiting their chances to launch, while other team members measured the rocket's apogee using handheld inclinometers. Figuring the actual numbers of feet the rocket traveled put students' math skills to the test as they applied their knowledge of trigonometry in this competition. High school students skipped the water rockets and proceeded directly to electronic circuit boards, which enhanced the LEGO Mindstorm NXT robotics experience. The students were able to build switches using circuit boards, resistors, capacitors, LEDs, diodes, and Hall effect sensors. The switches would light LEDs in a specific sequence when connected to the robots. They were also able to locate magnetic fields utilizing the kits. These activities allowed students to connect their electrical engineering skills with their programming skills and to see how various elements of STEM expertise meld together to accomplish goals.
I like to design different things, but I never thought of designing robots and making stuff work and move and interact with different things. And I learned more than I ever learned at school. Sometimes schools can't afford certain things and it's not hands-on. They just talk a lot and have books and things on the computer, where here you can actually hands-on and connect the pieces and figure out what's the problem to your solution.
For a portion of each day, students designed and prepared a technical presentation on an environmental exploration vehicle. This required students to create a concept design for a vehicle that was suitable to explore a tropical region. The vehicle design had to meet design specifications for the Navy. At week's end, students presented elaborate drawings, models, and prototypes as they explained the unique and creative design. Judges were STEM professionals who were duly impressed with the products. As the week of the Middle School STEM Institute drew to a close, students reflected on their experiences there.
It's definitely helped me out with deciding what math course I want to take. I was, a little bit skeptical of if I was ready to go on to a higher math, and just being here with the people at STEM, they've helped me build up my confidence, and now I know that I'm ready for higher maths and science, and it's all about studying and knowing that you can do it. So your confidence and study skills will help you get through just about any class.
High schoolers also shared their experience at the 2009 STEM Institute.
When I was 7, I was thinking more about being a basketball player or being a rapper. I didn't really pay attention in school much or even thinking about any engineering program at all. But now that I'm a 10th grader and I experienced the STEM program, I focus more on school because I know that I could have an injury or being a rapper won't come out right. Now that I've been through STEM, I've been told that taking harder math courses, the hardest, will put you in the best position. So I'll look forward to doing that and continue to read and do the best I can in school, make the best grades I can. so I can be successful in life.
Teachers now return to class having learned new skills and encountered new technologies and equipment. They have practiced their skills with the STEM Institute students, and they return to their classrooms prepared to engage their students in hands-on learning activities. When they implement their activities in the classroom, teachers have their engineers to invite to work with them, and their students, as they get students hooked on learning, get students interested in solving problems and in maintaining their interest in science and mathematics. Engineers have the opportunity to chat with students about the benefits and the requirements of a STEM career.
This is my second year of doing STEM, and I really love it. I use it in my classroom, and I work with students that are at risk of dropping out of school and in special ed programs, and they really seem to grasp a lot of the concepts a whole lot quicker and easier than somebody standing up there just trying to teach to them from a textbook. I think they get a whole lot more out of things by doing actual hands-on stuff, things that they can see, things that are tangible that they can touch, rather than some of the abstract thinking that we ask them to do in the class.
Funding through the National Defense Education Program via the Naval Surface Warfare Center, Panama City Division, this program was possible. By collaborating with Florida State University, Panama City, and the surrounding school districts, teachers have owned their skills in educating youngsters, engineers have extended their reach from the confines of NSWC to the classrooms of the area, and students have spent a productive week in the summer glimpsing the possibilities that lie in a STEM profession and a STEM career.
Our goal is to keep them interested and involved with science, technology, engineering, and math such that they proceed on to get a college degree and then would be available to work with Department of Defense.
What we were told when we came here was that the United States is low on engineers and that we need more because the kids are growing up to be other things and not many engineers. Doing this would help with the manufacturing of what we need, cars, computers, any kind of electrical stuff. So it would basically help the world go round.